this is the one that has the good property that if I restrict it to xt, this is just the canonical bundle on xt. So it's kind of set up for that. Okay. And I'm going to focus on, so I'm going to look at two cases. The first is when this kx over d star is trivial. So this is kind of the Calabi-Yau case. And in the second case, I want this to be, say, relatively ample. So it's ample when I restrict it to xt. Well, in principle, it's the third case when you have fauna or whatever, but I think that's not really so reasonable. Let me focus and just say something about the first case. So the first case, so in the first case, so then you also fix L. So this is a line bundle on X, which I'm assuming is relatively ample. So this just means that L restricted to kind of xt is ample. I mean, I didn't say xt is the fiber over t, right? Or something else. Okay. So this, if I have that, then by Yau means that there exists a unique, right? There's a unique omega-2 inside C1LT, which is Ricci flat. So this gives rise to the whole yoga here. So I mean, you have that, and that gives rise to, in particular, you get a metric space, which is xt dt. You also get a volume form, which should be, say, omega t to the n or something on x. And for 2, it's kind of, let me just, since I'm kind of running out of time here, so it's basically similar. So then the question I would like to address, I mean, perhaps the more interesting question is what happens kind of in a metric limit. So here's kind of the question. So what can be said about these objects? Right. So when I mean these objects, I mean, so you get, so if these are Calabi-Yau, you get some kind of metric space. And then it turns out that, well, there is a notion of Gromov-Hausdorff convergence. So you can put down a conjecture that these would converge in some Gromov-Hausdorff sense. And so that's very interesting, and not so much is known about it. And then I'll talk more about the case of what you can say about the convergence of these volume forms, which is easier to study, at least in this case. But you need to make sense of the statement, what the limit measure would be. All right, but we'll kind of take off from here next time, so I'll stop here.